The next question in front of you is given that let fx is equals to cos x and gx is equals to 1 minus x square by 2 for x belongs to minus pi by 2 to pi by 2, right? And there are following options given and we have to mark the correct answer. So first let us try here that we know that here cos x, this can be written as 1 minus x square by 2 plus x to the power 4 by 4 minus x to the power 6 by 6 and so on till infinity, and gx is given by 1 minus x square. So from this expansion this is very clear that of course gx is greater than this, right? Because this is it's at x square minus 2 and here we keep on adding and subtracting larger and larger numbers, so of course gx is greater than or equal to fx. Now we can also show that using the diagram, right? So let us draw a plane here. Okay. Now for cos x, for x belongs to minus pi by 2, we have this. We can draw this one like this. Y. So here we know that minus pi by 2, this is 1. At pi by 2, this is 1. And at 0, cos 0 is 1. So minus 1, 1 and 0. So this is how we can draw it, right? Now we can draw for gx. Now so we know that gx is equals to 1 minus x square by 2. Now let us say let y is equals to 1 minus x square by 2. So from here we have x square is equals to 1 minus y. So 2 times 1 minus y, right? Minus. We also have a minus here. No. We don't need minus as we have written 1 minus y. So this. Now, so from this is clear that the face of the parabola here will be from this side to this side. Now we have to calculate the vertex point here. So for that we will try to find out the value of y with respect to x, as x belongs to minus pi by 2 and pi by 2. Okay, now this can be written as x square is equals to minus 2 y minus 1. So this is clear because of the minus, this will be this words facing. Now we have to find out where this parabola will cut the x-axis. So it will cut the x-axis when x is equal to 0 in order to find out the y is equal to 0 in order to find out x square. So when y is equal to 0, we can see that x square is equals to 2. That is x is equals to plus minus root 2. That means here we have root 2 and here we have minus root 2. So the here, and this is bounded here, right? So this is gx, and this is fx. Okay, so this is very clear from this point that of course gx will be greater than or equal to the given fx, that is sin x. So what is the option? Greater here. So option B is the correct answer. The next question here is given that S and T be non-empty subsets of R square and W be a non-zero super subspace of R square, right? So consider the following statement, that is if span S is equals to R square, then span S intersection W will be W. So this is whether this is true or false, that is what we have to test, right? Now so S here basically, so S will be here 1 comma 0 and 0 comma 1 is a subset of R square, and W here is basically 1 comma 1. Now if we take the intersection of these two sets, then of course this is phi, and phi is not equal to W because W we have this, so that means the statement is false. That is the answer. The next question in front of you from our question paper of IIT JAM Maths shows that there is T such that the polynomial of 2 to P4, that is polynomial of 4, the linear transformation given by Px is equals to P of x square, where P is again here we are talking about polynomial, then the rank of T is how much? So in order to find out, let us first write down the polynomial. So if it is 2, so then we can write down a0 plus a1x plus a2x squared. The 4, it is a0 plus a1x plus a2x squared plus a3x cube plus a4x to the power 4. Right. Now from this here basis, it's clear that it is 1x squared, right, here, here, and for t4, that is here, we will have 1 x squared, x cube, x4. Okay, now the relation given here is t of px is equals to t of x squared. Now t of px here is this is a0 plus a1x plus t of px is t of a0 plus a1x plus a2x squared is equals to p of x squared. So we will put x squared in this, that is a0 plus a1 x squared plus a2 x to the power 4, right? Now what we have to do is we will take this basis. So when it is t1, so for t1 from the basis, so 1, that is t of I need 1, so this is 1 plus 0 into x plus 0 into x squared, that is equals to, so a0 is 1, so 1 plus 0 into x plus 0 into x squared plus 0 into x to the power 4. When it is x, so t is equals to, this is 0 into a0 plus 1 into x, so that means this is 0 plus 1 into x. So a1 into x, right? So this is 0 into x plus a1 is 1 into x squared plus 0 into x4. When it is x squared, so t 0, 0 plus 0 into x plus 1 into x squared. So a2 will be 1 here, that is 0 plus 0 into x plus 0 into x squared plus 1 into x to the power 4. Now if we write it down in the determinant format, so the matrix we will get 1 0 0. Okay, then for x squared we have 0 1 0, and for x4 we have 0 0 1. So it's very clear that here I have one element, one element, one element. So the maximum rank for this matrix T, so this T matrix is equals to 3. That is the answer.